Hello friends, welcome back. You can see here I have created a project with the name mathf demo. Then in the assets folder I created a folder with the name scripts. In the scripts folder I have created a C# file with the name math demo. I have already attached the math demo C# file to the camera, you can see that, and I have opened that in the MonoBehaviour. In this tutorial we are going to discuss about mathf structure, my friends. Mathf structure is really useful structure for us as a game programmer or a simulation programmer or any application developer. Now here you can see I have the documentation already opened. I just search for mathf structure, mathf. There are 52 matches. Let us select the first one. And here you can see that mathf description says a collection of common math functions. Now mathf structure is actually a collection of mathematical functions which are most commonly used in games or simulations or any applications where you will be having mathematical operations. And mathf structure, you can see that its members means variables or methods or functions, understanding. These members are static. You can see that mathf members are all static members, guys. We understand in this tutorial you people will understand what is little bit information about static, returning, not returning, void. Some information you guys will get. It's really useful. So let's get started. Here we have, before I proceed to the mathf structure, I just would like to talk about debug.log class. Now here we have debug class. Let me discuss about debug class. The debug class is one of the useful class. You know that because from the beginning we are using that to display something on the screen. Now let me right click and say go to declaration. Now what the MonoDevelop does, guys, you know that it will open the assembly browser and shows me the debug class. Debug class is present in the Unity engine namespace, that you can see that, and that is the reason we are writing here using Unity engine, right? And the debug class has a method with the name log or a function with the name log, and it's a static function, guys. It's a static method and it is publicly available so that I can access this anywhere I want. Now let us understand the methods and the properties or variables or functions. These are all members of some data structure. In our case at present, debug class is a data structure which has many members, and one of the most important member is a log method, which is a static method, guys. And if I want to use this method or any member is a static, you can use it or access it anywhere else by using the class name or a data structure name. You can say a class or a structure. It's a data structure, guys. So here we have a debug class. We have written the class name because if I want to access the log method, I have to write this name there, or this class name debug I have written. Then I need to put a dot. If I put a dot, what system does means it shows all the members that I can be able to access. Now what is a dot? Dot is a member access operator, guys. It is a special operator. It's a member access operator. Try to understand. Okay. Now here debug is a class name. Once I put a dot, I can access the members inside it. So I am going to write here log, right? Now log is a static method. You can see that any member is a static. You can access it by using its class name or its data structure name. Now debug.log I have written. Then one of the most important skill of a programmer is to know how to use a method. Now here we are understanding how to use a method log. Now first thing we need to see what it is asking for, what parameters it has. It is asking for a message, so I give a message to it. Hello Unity. Good. And I also need to see what it is returning back. You can see that we have void. Void means it is not returning anything back. That's cool. Now we know that debug.log what actually it does. What it does, it takes this hello unity and displays it on the console window. Right guys? Cool. Here similarly we have a mathf structure. It is a structure, struct. Can you see that? We are using a keyword struct. You people will understand a lot of things step by step. Don't worry about if you are not understanding anything. If you are not understanding something, just make a note if you have a doubt, and definitely it will be cleared step by step in a further tutorials. Now, we have mathf structure. In mathf structure, we have many members. We have variables, we have functions, and there is a function with the name abs. Abs returns the absolute value of f. F means f is a field, or what do you say, f is a parameter in the absolute. You need to pass a value actually to that f variable. Now absolute is a function which is a static function, you can see. So if I put a dot is a member access operator. It is showing me all the methods that I can be able to access, or all the members that I can be able to access. One of the member that I can be able to access is the absolute, abs. ABS returns the absolute value of the value that you pass. You can see that first thing I am going to check what it is asking for. It is asking for an integer value. So I give -8, bracket close, semicolon. And I also check what it returns back. You can see that it is returning back an integer. It is not void here. It is a integer guys. That means it returns an integer value back to us that we can take and use. Are you guys understanding? That means what I do, I say here debug.log and I give to the log method mathf.abs of -8. Now first thing you need to remember guys, when you are calling in such a way, always the innermost method call is going to get executed first. So what happens here means when the system comes to this line, or a control comes to this line, what it does, it will first execute this inner statement, that is mathf.abs of -8. What abs of -8 does, it returns the absolute value of -8, that is 8, right? Absolute means what? Positive value, right my friends? So it returns 8 back, and that 8 will be taken by the log method, and the log method will display this 8 on the console window. Now let me show that so that you guys can understand. I just save this much, and let us come back to the Unity, go to the console window and run and check. And if I run here, you should get the 8 guys. Okay, it's taking little time to compile and create other files. Yeah, we got 8. Can you see that my friends? Yes, that is the operation or task of ABS method. You can check for any other number. If you write -9, it gives you 9 back. I just run this code and you should see here 9. You see that you got 9. Super, right? So another thing you need to point here is absolute function. There are 2 absolute functions in the mathf structure, not only one. The first absolute function takes an integer, returns an integer back. The second one takes a float, returns a float back. That means it returns an absolute value of a floating number. That means you can try for floating point value also. Understanding? Let us take an example of if you give -9.8, -9.8 I have written, we will get an error message if I pass -9.8. Do you know what error we get guys? I think you already know. Can you guess? Let me show that. The error we got is argument 1 cannot convert double expression to type float, and it is telling the best overloaded method match for Unity engine mathf.abs is a float guys, has some invalid arguments. It is telling that you are passing a double, but there is no method called absolute which takes a double and returns back something. Either you have to pass an integer or you have to pass a float. So if I have to pass the float, I have to write here f at the end. Now this is going to be a floating point value which is negative 9.8f, but we get the return value as 9.8. Let us save and come back to Unity. You will not be having the error messages now. Clean and clear console window. If I run the code, you are going to see here 9.8. That is the meaning of ABS. And what is the meaning of overloaded method? Absolute function is the overloaded method. Overloaded method means there are more than one functions with the same name but performing the different task. That is the meaning of method overloading. So here ABS is a method overloaded method, I can say, right? So I hope you guys have understood now what is the task of ABS function and how you can use it. Let us proceed. Now in mathf structure we have some other functions like round to integer, right? Let us take round to integer just to understand. The round to integer is the only one method. It is not an overloaded method, you can see that, and it is asking for a float value. If you give a float value, it will return an integer, a rounded number. I think already you know what is the meaning of round, right? Let us check it out. One small example for that. Let's write 2.5. If I write 2.5, I have to write f. Don't forget debug.log mathf round to int I have written here. Now let us understand, guys, here what happens. First, the innermost method call is going to get executed, round to int. It takes 2.5 and returns a rounded value. Now what it does means it will see if the value that you have passed, understanding, is less than or equal to 2.5, it returns the nearest value, that is nearest lowest value, that is 2, an integer value, I can say, nearest lowest integer value, it returns back. So here you can see 2.5f. For this number, the nearest lowest integer value is 2, guys. So it will give you back 2. Let us save, come back and run and check. You can see that we got 2. Now let us clear this and check out. If the number is, as I told, if it is less than 0.5, 2.5, you can see it's the 2.2 now. Nearest lowest value is 2. Integer value is 2. So we get the result 2 on the screen. You should see here the last output 2, guys. We got 2. You can see that. If this number is greater than 2.5 or like 2.6, 2.7, 2.8, 2.9 up to 3, it will give you the 3 as a return value. Let us save and come back and run and check. You can see that you are getting 3, guys. Now you can understand in the documentation, I just use Control F and check for ROUND, round to int. What it does, returns f rounded to the nearest integer. Can you see that? Round to int returns a number, an integer number which is nearest. Understanding? So let's proceed and get some more information. We are going to understand the next one, which is mathf dot let us take seal. There is a function called as seal to int. You have seal also, you have seal to int also. Please go through the documentation and understand. I just give you few brief informations. Now seal to int takes another floating number. It returns an integer back but sealed, right? Let us check it out. Let me write here 2.5f. Then in the beginning I say debug.log. I can say here bracket close. Let us save and see the documentation. Documentation, seal means top, floor means down. Try to understand. Seal means upward, floor means downward. Now let me check for seal, C-E-I-L, seal to int. Returns, seal to int returns the smallest integer greater to or equal to f. An integer greater, it takes you to the top side. Let us check it out here. If you write a number between 2 to 3. Any number you write, it always gives you 3 on the screen. Seal. Let us save and check out. For 2.5 you should get 3, not 2. The last output should be 3. You can see that you got 3 guys, right? Clear? Now if you write even 2.1, it will not display 2, it will display 3 guys. Let us save, come back and check it out. If I run the code, you can see that you are getting 3. Understanding? That is the meaning of seal, which is present in the mathf structure. Even if you write 2.6, you will get 3. Understanding? Then let us check next one. mathf.floor. There is floor, floor to half, floor to int, half to float. Please check it out, these things. Floor to int, I am giving 2.5f again. Here I say debug.log and show you what it does. Now mathf floor to int, what it returns back means it returns the nearest lower integer always. So that means it will always give you 2 now. If you write a value between 2 to 3, any value you pass, it will give you the nearest lower number, that is 2 it will display. Let us see now. If I run the code, you should see the last output as a 2. You can see that you are getting 2 guys. Understanding? Even though you write 2.9 and just save it and run and check, you are going to get 2 only, not 3. That is the meaning of floor to int, guys, or floor. Floor means downward it takes you, seal to int takes you upward, round to int takes you depending on the number that you pass. If the value you have passed is less than less than or equal to 2.5, you get 2. If it is greater than 2.5 and 3, up to 3, you are going to get 3. Understanding? You can check for any other numbers. You can write 3.5 or 9.5. Check what result you get. Okay? Try to experiment yourself. Now we have understood what is the absolute, what is round to int, what is seal to int, what is floor to int. Let us see some more examples. We have mathf.power. There is a function with the name power. You can see that it takes 2 floating point values and returns a float back. So it asking for first value. Let us take 3, 2 I will pass. 2 values I have passed here. Now you can search for power, what it does. POW. Power. Here we have power. Returns f raised to the power of p. It is telling that you are going to get a result 3 raised to the power of 2. And what is that, guys? That is 9. So I write here debug.log and see the result. I should get 9 on the screen. You can see that we got 9 guys. So I hope you guys are understanding how it is working. So power you have understood. We have other methods called as square root. You can see that returns the square root of f. So let us check it out. mathf.sqrt, square root of 9. Let us check it out for square root of 9. And first of all I need to check what it is asking for. It is asking for a float. So I am going to pass 9.0f. And let us check it out. Debug.log. It returns the square root of 9, guys. So I should get 3. The last output should be 3. Let us run and check. If I run the code, you can see that we got the value 3, friends. That is about the square root function. I hope you guys are understanding how you can use these functions. They are really useful. Let us proceed and see some other functions that you can use. mathf dot anything else I can use. We have an 8 and 2 function. We have sign function. We have cos function, right? Let us see here. mathf dot cos of, now mathematical sine, cos, tan or trigonometric functions are actually going to take the radians and return back in radians. They take the angle in radians and return back the values in radians. So when you people will learn about angles in future tutorials, you guys will understand how do we represent angles. We usually represent the angle in degrees and radians. You people will understand how to convert degrees to radians, how to give values to the mathematical, these sine, cos functions and all. You are going to understand them little later, guys. Okay. So let us check it out, some other functions. I will explain about trigonometric functions later. Right. Here we have another function known as a clamp, which is really useful. If you want to clamp a value in between minimum and maximum, you can use this one. Let me explain actually. Let us write here 50, 0, 100. See, the minimum value I am giving 0, maximum I am giving 100, and the value I am passing 50, and it returns back an integer. That also you can see. So here I write debug.log. Let us check it out what it does and understand. Now let me tell you guys, this part is important because this method is important. The clamp function takes a value. You are going to pass a value here. If that value is in between this range, then you are going to get that value back. That means you can see that 50 is in between the range of 0 and 100, so you will get the 50 output on the screen. Let us save and come back and run and check. And you can see that you got 50, that is good. If your number is lesser than 0, you can see that the value is minus 50, which is actually less than 0. Then what this function does means it clamps that value to 0. Understanding? That means if I run and show you, you will get the 0 as the last output, not minus 50. That is the meaning of clamp. You can see that we got the value 0, guys. Let me clear this. And if your number is greater than the maximum value, let us take 500 I have written, then it will clamp to the maximum value 100. That means you will see the output, it returns 100, not 500. Let us save, come back to Unity and run and check. You can see that you got the value 100, guys. And you can even search here what it does. CLAMP, clamp. Clamps a value between a minimum float and the maximum float value. Can you see that? Understanding? Even you have clamp 01, clamps a value between 0 and 1, returns a value. This is also very useful function. Later we will understand what is this clamps value between 0 and. You can understand yourself also. You can see the documentation. There is no problem in that. Now let us take another function, mathf.lerp, which is also one of the useful function. You can see that it takes from value and to value and a t value. It returns a float back. Now I will explain. This t value must and should be between 0 and 1. We understand step by step what actually it is now. So from let us take 0, to let us take 100, and t let us take 0. And here I go debug.log mathf.lerp bracket close semicolon. I just save it. Guys, here you have to understand what is lerp, and let me explain from the documentation so that you people will be much more clear. LERP, lerp. Now lerp interpolates between A and B by T. Try to understand. Interpolates between A and B by T. T is clamped between 0 and 1. So the value you have to give between 0 and 1. If you give more than 1, it will clamp to 1. If you give less than 0, it will clamp to 0. That is also they have already written. So here we have 0. What system does means it will display 0 on the screen. Let us save and come back and run and check. You should get the last output as 0, guys. You can see that we got 0. That is good. Now if I give here 1, then what happens means it will display 100, guys. Let us save, come back and run and check. You can see that you got 100. That is good. If I give here 0.5f, then what you get means you will get the middle value in this range. The middlemost value in this range is 50. Let us say 0.5 means half, right? 50. You are going to get here 50, guys. That is the value use of lerp, linearly interpolate. You got 50. This is really useful in future. Now you can see the code, what exactly present in the lerp function by right clicking, say go to declaration. You can see it is doing some mathematical calculation and gives you a value between the range based on the t value. Even you have some other functions like right click, go to declaration, power. What actually math power, this power function actually calls another function with the name power, which is in the math class actually. Now math class is actually a part of .NET framework, guys. Internally your Unity is using the .NET framework to do some calculations. In the .NET framework you have a math class. Actually power function, you can see that implicitly it is calling a power function in the math class of the .NET framework. This math is actually present in the system namespace. You can see that they have written here using system. You can see if you want also, if you click on this, it will take you to the math class which is in the system namespace, and you can even see that system namespace is present in the MS core lib. Right, guys? So I hope you guys are understanding how you can access the members of any data structures if it is a static member and how you can use that. It is not necessary that you need to put this part in the log method. If you want, you can create one variable, integer variable, and say maybe absolute of num is equal to, let us take mathf.abs, control X and paste here semicolon. You can take the result of mathf absolute of minus 9.8 in this variable abs num, and you can copy and paste here, and whatever it returns, that will be stored in this variable abs of num. It is going to have 9.8. that 9.8 will be given to the log method, and that will display 9.8 on the console window. Let us save and see. We have an error. The reason is that cannot implicitly convert type float to int. So here I should be having the float because abs function returns a float. Let us save, come back to Unity and run and check. And you should see the topmost result should be 9.8. Right, my friends? So please go through these functions. I suggest you people please go through these functions. They are really useful functions in games or simulations. And here you can see there are few variables like pi, which is very useful constant, 3.141. You have epsilon, a tiny floating point value. Many places we use it with this constant to clamp a number, a very small floating point number to 0 or something like that. You can convert degrees to radians by using this variable. You can convert radians to degrees using this variable, which are useful. Infinity, which is used to represent a positive infinity. Negative infinity is used to represent the negative infinity. They are really useful variables. You can use, if you want pi, you can see by writing mathf.pi. You can see that its value is 3.141593. You can use this pi whenever you want. Let us take an example of, you have a variable called radius is equal to 4, and you want to find out what is the area of the circle created by this radius. So very simple, you can say debug.log and say what is the area of a circle? Pi r square, right? So I can write here mathf.pi multiplied by r, or you can use mathf.power of r comma 2 bracket close semicolon. So here you can understand what system does means first it comes to this line and it first executes this code. What this code does, mathf power r2, r is 4, 4 raised to the power of 2 it will do, 4 raised to the power of 4 it will calculate, not 4 raised to the power of 4 raised to the power of 2 it will calculate. So 4 raised to the power of 2 is 16. 16 multiplied by 3.142 it will do, I think almost it is around 48 points or 49 in between, right? Let us save and come back and check it out. And you can see that, yeah, it's 50.26548 something. That is the area of a circle created by the radius of 4. So you can use these mathematical functions in many places in different ways. I hope you guys have understood what mathf structure is. Internally, in many places, mathematical functions or the functions in the mathf structure are actually using the math class which is present in the .NET framework. That's it, guys. I want you people to see what code actually written in the mathf structures methods. Even I will explain you, or we will create our own functions like power, float to integer, or some other functions we will create and understand how it is written actually behind the scene. And you have other functions also, like mathf.max is a function which is a overloaded function. 4 overloads are there, that means there are 4 max functions. It actually returns a maximum between 2 integers, maximum between 2 floats, maximum between array or list of integers, maximum between list of floating point values. Let me show here 1, 2, 3, 4. If I pass like this, what it does means debug.log. You can see the maximum of these values. You are going to get 4 now on the screen. If I save, come back to Unity and run and show you, you will get here the last output should be 4 because 4 is the maximum in that list. This is how you can use, even you have the min function. I think for this tutorial this much is enough, guys. So keep learning, keep coding. See you in the next tutorial. Thank you guys. Thank you very much.